Right, this lesson is going to be broken into a couple parts just because there is a lot of work involved. So I just want to recap when we were solving equations that had two letters in it. First things first, to be classified as an equation, you have to have an equal sign. Well, you guys were doing systems of equation. A system means that you have more than one equation in one problem. Right? And then there were three ways that we were using to solve those systems. One was substitution, the other was elimination, and then the last one was graphing. So when you graph a system, you get one of three possibilities. Your lines looked like that, so they would have no solution. They need to intersect to have a solution. So if they're parallel, that means there's no solution, and vice versa. Or your lines would have crisscrossed and they'll only touch one time, but right here would be your solution. And then the other scenario is if you actually end up graphing your first line and then your second line, and they lay right on top of each other, and that is called infinite solutions. So when you're doing a two-variable system, you get one of those possibilities. Now, when we do a three-variable system, so in other words, we have x, y, and z in the problem, the graphing is a little bit more complex. It's a little bit too complex for Algebra 2 in high school. So we are only going to use substitution and elimination. All right, so you'll typically be presented with a problem that looks similar to this. And you notice how you have your x's, your y's, and your z's all stacked nice and neat. If that happens, you want to use elimination. So step one is you're going to label them A, B, and C. That way you have something to revert back to when you're trying to name what you're doing. Step two, you're going to pick two of these. So it doesn't matter if you want to pair up A and B, A and C, or B and C. It does not matter. You're going to pick two of them, and you're going to stack them up. So we'll go ahead and just because use A and B. You're going to copy your A equation, and then you're going to copy your B equation right under it. Then you're going to pick a letter that you would like to eliminate. So it does not matter which letter you pick. I choose to eliminate my x's. So that's what I'm going to do. So to make that happen, I'll have to multiply the top row by -2. So we're going to distribute the -2. And this is my new top. The bottom does not change. And then we can add the system or the equations together. So x's go away. You get -3y, 4z, and -13. Now you did not get an actual answer yet. You still have letters, but notice how you only have 2 letters now. So that means we're making headway. You want to go ahead and put a box around that because we're going to need it later, and I want it to be really easy for you to find. And step 2 is done. All right, so step 3, you're going to pick 2 different equations. So you may pick B and C to use, or you can pick A and C. So it just has to be a different pairing than A, B. I'm going to go with AC, and the first thing I'm going to do is going to copy my A equation, and then I'm going to copy my B equation. Now here's the catch. You made a commitment, a decision that you're going to eliminate x's. In the last problem, x was the one that you crossed out. You have to honor that commitment and stay true to it. You have to keep eliminating x's. You can't change your mind and say, oh, I'm going to get rid of the z's now. That won't work. So to make my x's go away, I'm going to multiply by -4. Copy over my bottom equation, and then I'm going to add them together. And when I do that, that's my lovely answer. Notice how it only has 2 letters in it. That's exactly what we want. And you're going to draw a box around it. And then step 3 is done. Step 4, you're going to take your boxes that you just got and you're going to stack them on top of each other. It does not matter who you put on top and who you put on the bottom, but you're going to stack your boxes, and then you're going to do elimination one more time. So we either get the y's to match up or we get the z's to match up. We're going to have to change both equations to make that happen, so I'm going to choose to get the y's to match up. I'm going to turn 3 and 5 into 15, and that's how it's going to be done. Now the other catch is both of these are negative. one of them should be positive. So either the 5 or the 3 needs to be negative. So I'll multiply the top by -5 and the bottom by 3. And that's what I'll get when I do that. And then if I add, I'll get 19z equals -19. And there's my very first answer. So now I know that z is -1. So step 4 is done. Right. Now you have to go back and get your other letters. You have an x and a y still. So what we're going to do is we're going to put our z into one of our box equations. If you put it back into the original starting equations, you're not going to be able to solve it because you don't know enough letters. But you can make it work with a box equation. So I'm going to take the top box, -3y, 4z, and -13, and I'm going to put -1 in z's spot, and then I'm going to solve for y. Now I know what my y is. Once you know z and y, you can take both of those and plug them into one of your starting equations from the very beginning. I know that x plus 2y minus 3z equals 11 was a starting equation. So just because I just picked that one, it does not matter which one you pick. And I'm going to fill in my y and z values, and I'm going to solve for x. So now I know x is 2. So we are going to do another one just because it was a lot of work. It's mostly multiplying and adding, but we just want to make sure you feel comfortable with the process. So we'll go ahead and do that again. Let's call them A, B, and C. They're all obviously stacked nice and neat, which is why I'm using elimination. And then I'm going to pick 2 letters. I'll just do A and B again. Copy those equations. And then you want to pick which letter you would like to get rid of. I'm going to go with my Z's this time and get those Z's to match up. And if we add, we'll get 4x minus y equals -5. And you want to draw your box. So we're eliminating a letter and then drawing a box around our answer. And then we pick 2 other equations to match up, maybe A and C or B and C. I'm going to do BC. I'm going to copy my B equation and my C equation. And I made a commitment that I'm going to get rid of the z's. So that's what I have to do here. I have to make the z's go away. So if I multiply the top row by 3, I can do that. And we'll go ahead and add. And we get 9, -14, and 24. And then draw a box around it. Then we're going to stack our boxes. And we're going to eliminate one more time. I'm going to choose to get rid of the y's, so I need to multiply the bottom by -14. And that's what I get when I do that. And then I'm going to add, and I'll get -47 on one side, I'll get 94 on the other, and that's going to come out to -2. So there's my answer for x. So again, we get our first box, we get our second box, the letters need to match, and then we stack them and then do one more round of elimination. Now that I got -2, I can plug them into either box, it doesn't matter. I'm going to use this box right here, and I'm going to fill in that x. I'm going to solve that for y, and I'm going to get -3. That one's done. Once you know 2 of your letters, go back all the way to the very beginning, and you can pick any of these equations to use. I think A will be the easiest, so I'm going to go ahead and put my x value in, my newly found y value, and I'm solving for z. And that answer is going to become +4. So in our next video, I'm going to go ahead and have you do a word problem and use your elimination technique to do that.